Hello. So, uh, this is my first lecture on my YouTube channel that is Fitiki. As the name suggests, uh, I'm going to use both English as well as Hindi to deliver my lecture. So, हमने ये चैनल मेनली उनके लिए बनाया है जो इन फ्यूचर जीएस, टीआईएफआर, सीएस, आईआर नेट, आईआईटी जैम के लिए प्रिपरेशन कर रहे हैं और करेंटली हम सिर्फ फिजिक्स पार्ट को इसमें इस चैनल पे डिस्कस करेंगे। अभी जैसा कि हमें पता है कि 12th ऑफ अप्रैल को हमारा जेस्ट का एग्जाम है। सो हमने पहले इस पे सिर्फ जेस्ट के कुछ प्रॉब्लम्स और उस प्रॉब्लम में फिजिक्स के किस टॉपिक के किस कंसेप्ट का यूज करना है, हम जस्ट उस कंसेप्ट को जस्ट लाइक कैप्सूल कोर्स में हम उसको एक बार देख के आगे बढ़ेंगे। एंड I will discuss some problems that already asked in the previous exams. So let me start with the basic discussion. So I'm going to upload some around 4 or 5 lectures or the videos on quantum mechanics that cover all the basic concepts and the question that we already asked in the exam. So today this is my first lecture. So as you see, the first line is just ignore my mistakes and appreciate my effort that I'm making to you for how to prepare for the JEST exam. So let me start with the very basic introduction with the quantum mechanics. We all know the Schrodinger equation. That is nothing but H psi is equal to E psi. And this is the operators. So we have a time independent Schrodinger equation and time dependent Schrodinger equation. So we all know our H is nothing but minus H cut square by 2m del 2 plus V as a function of x. If I am just in the one direction, so for one direction, this delta 2 is nothing but d2 by dx square. And our energy operators, if I am using the time dependent Schrodinger equation, then our energy is iota h cut del over del t. And we all know that momentum operator minus iota h cut d over dx. So also we know the psi is known as the wave function. The postulates of quantum mechanics. So there are some conditions that psi has to satisfy: the normalization condition, single valued, finite, continuous. All these conditions has to satisfy for psi to be an admissible wave function. Now we all know that we are doing all this discussion in the x space, that is in coordinate space. We can discuss all the things in momentum space as well. So can it be possible for us? So if we our psi as a function of x in the x space, can we move to psi as a function of p or psi as a function of k? What are the transformation rules that one can use to go from coordinate space to momentum space? So in the examination, mainly they will wrote what are the transformation rule they are using. Means the Fourier transform वहां पे लिखा होता है कि किस Fourier transform को हम यूज कर रहे हैं. दोनों तरीके से आप कर सकते हैं. So हम यहाँ पे यूज कर रहे हैं कि हमारा f of x, any function of x, is going to be 1 by root 2 pi h bar integration from minus infinity to plus infinity f tilde of p, f as a function of p, e to the power iota px by h cut integration of dp. समटाइम कुछ बुक्स ये भी यूज करते हैं कि fx is equal to this constant integration f tilde p e to the power minus iota px by h cut dp. किसी भी डिफिनेशन का यूज किया जाए आंसर को कोई फर्क नहीं पड़ता है, बट द always someone ask you to find the Fourier transform, they will give you what type of formula we are going to use. एग्जाम में भी जब Fourier transform का क्वेश्चन आता है तो वहां पे लिखा होता है कि हम किस रूल का यूज करने जा रहे हैं. सो P में एक एक्स्ट्रा फैक्टर h कट का यहाँ दिख रहा है, सो हम ये भी लिख सकते हैं कि f of x is nothing but 1/√2 pi इंटीग्रेशन माइनस इन्फिनिटी टू प्लस इन्फिनिटी f टिल्डा k e to the power iota kx dk. This is what we are going to use. Also, you don't know that in the quantum mechanics, everything is in the operator form. Either your energy as iota h cut d over dt, our momentum minus iota h cut d over dx. And also we want all these operators to be Hermitian, because the Hermitian operators gives the real eigenvalue, and we are going to measure these things in quantum mechanically. So अगर हमारे पास कुछ imaginary होगा तो हम क्या measure कर रहे हैं, कुछ measure नहीं कर रहे हैं. So हम सिर्फ इनके जो eigen values होंगे वो Hermitian होंगे, but these operators are in the coordinate space, that in x coordinate space. What about the operator in momentum space? In momentum space, the momentum operator P is going to be just P, but our x operator is going to be iota h cut d over dp. One can prove these relations if when we start some discussion on quantum mechanics, I will definitely prove this relation. And in the coordinate space, our x is just x. Energy is same in both the operators, either in coordinate space or momentum space. Okay. You also know that when we are going to take x dagger is equal to x, it means they are Hermitian. But when we are going to find d by dx dagger, this is going to be minus d by dx. So the physics behind that, when I am saying that d by dx dagger is equal to minus d by dx, it means अगर हम d by dx को अपने एक के टेस्टेड साई और एक ब्रास्टेड साई पे अगर हम इस तरफ लगाएंगे तो जो हमारा रिजल्ट आएगा, जो भी है, मैं इस पर डिस्कशन नहीं कर, जो साई होगा उसके अकॉर्डिंग टू रिजल्ट आएगा. और अगर हमने साई d by dx साई पर अगर हम इस तरफ लगाते हैं अपना ऑपरेटर, तो यहाँ जो रिजल्ट आएगा वो एक माइनस साइन एक्स्ट्रा पिकअप करेगा, बिकॉज d by dx डैगर इज गोइंग टू बी माइनस ऑफ d by dx. सो इसलिए भी हम ऑपरेटर को हर्मिशियन खोजते हैं कि आइदर हम ब्राय स्टेट पे एक्ट करें या केट स्टेट पे एक्ट करें, हमारा रिजल्ट सेम हो. सो यू कैन चेक डायरेक्टली दैट माइनस आयोटा एच कट d by dx डैगर इज सेम एज minus iota h cut d by dx. One can also show that e to the power some operator a dagger is same as e to the power a dagger. One can also show f of x dagger is equal to f of only x dagger. But when we are going to find the expectations value, you know that when we find the expectation value in some state psi, so psi p psi, you find either in position space or in momentum space, you are going to same value. Just check. Just always used to ask these type of questions, that we have something in coordinate space, what is the relevance quantity in the momentum state. You also know about the commutator algebra, that when we have a comma b commutator is equal to ab minus b, where a and b's are going to be the some operators. You also know what is the formula for ABC. A comma B C minus B A comma C. I'm just ignoring the hats, but hats are there. So one can prove what is the commutator for any function of B. This is nothing but commutator of A comma B into f of d of f of B divided by dB. At the same time, if A first is a function of A and we have find out the B, then we have A comma B d f of A by dA. ये भी पता है कि अगर हम डेल्टा ए एंड डेल्टा बी करें तो दिस इज ग्रेटर देन इक्वल टू 1/2 commutator of a comma b, where delta a defined as root under expectation of a square minus expectation of a square. ये हमें पता है कि ये कैसे होता है. जो कि सबसे पहला एग्जांपल हम जब क्वांटम मैकेनिक्स पढ़ते हैं सबसे फर्स्ट एग्जांपल हमें पढ़ाया जाता है इनफाइनाइट पोटेंशियल वेल, कि हमारे पास एक वेल है जो कि 0 से L तक है. Inside the potential is going to be 0, so we are writing our potential as the following: 0 and infinity from L to 0, and for otherwise we have an infinity. हम इसके लिए अपना श्रोडिंगर इक्वेशन सॉल्व करते हैं. माइनस एच कट स्क्वायर बाई 2m d2 बाई dx स्क्वायर साई प्लस पोटेंशियल टर्म इज 0 इज इक्वल टू ई साई. जब हम ये सॉल्व करते हैं तो हम यहां से निकलता है. So after normalization so psi of x is equal to root under 2 by L sine n pi x by L, and our energy is going to be n square pi square h cut square by 2m L square. In general, the psi x is nothing but integration 2 over box size into sine n pi x over box size, and our energy is going to be n square pi square h cut square by twice m box size whole square. For this case, your box size is L, 0 to L, L minus 0 L, so L, L, L square. Okay, so this is what we just wants to discuss these things. So let me discuss some problem that asked in just examination. So previous year problem, I am going to discuss some previous year problem. So there is one question that you have given some psi, you have a psi given as exponential minus x square by 2 cos hyperbolic root of 2x, and you have to find out what is the potential for this wave function. This is our first question we are going to discuss. So as we know from the Schrodinger equation that minus h cut square by 2m del 2 of psi is equal plus v of psi is equal to e of psi. In the question, they are arguing that you can fix your h cut is equal to 1, your mass is equal to 1. And this Vx, you have to find the Vx for ground state. What is the potential for the ground states? So for the ground state, we can also use all the constant to be negatives, 0. So this part is also going to be 0. So I'm going to just use plus 1 by 2m del 2 of psi plus v of psi is equal to v of psi. So using this psi, we can just differentiate twice and we can find what is our delta 2 is. So delta 2 psi, or let me use just d over dx into d over dx of our psi exponential minus x square by 2 cos hyperbolic root 2x. So d by dx of, let me differentiate first. So exponential minus x square by 2 into minus x cos hyperbolic root 2x plus exponential minus x by 2 sine hyperbolic root 2x root 2. So I can take the e to the power minus x square common, e to the power minus x square by 2 common. We have minus x cos hyperbolic root 2x plus root 2 sine hyperbolic root 2x. Clear? Now again, and we have to again differentiate once more. So again differentiating, we have e to the power minus x by 2 into minus x, and what is there inside that box, plus exponential minus x square by 2 into, let me differentiate the inside. So minus cos hyperbolic root 2x minus cos hyperbolic root 2x minus x sine hyperbolic root 2x. First I'm differentiating x, so only cos hyperbolic root 2x, then cos, then sine hyperbolic root 2x into again a root 2. This part plus root 2 cos hyperbolic root 2x into root 2. Again I am taking all the minus x square by 2 common. We have in the first para we have minus plus x square cos hyperbolic root 2x, again minus x into this, plus root 2x sine hyperbolic root 2x. This is minus cos hyperbolic root 2x minus root 2x sine hyperbolic root 2x plus 2 cos hyperbolic root 2x. Am I correct? Oh, see, this is plus and this is minus, so this is minus. Okay, so we have e to the power minus x square by 2 x square cos hyperbolic root 2x. These two combines and we have minus 2 root 2x sine hyperbolic root 2x, and these two are just cos hyperbolic root 2x and 2 cos hyperbolic root 2x, so we have just plus cancels are just cos hyperbolic 2x. If I'm not wrong, this is what we have. So we have 1 by 2, sorry, again, so our wave function is like e to the power minus x square by 2, and if I take just cos hyperbolic root 2x common, we have x square minus 2 root 2 x tan hyperbolic root 2x. Okay, so just I am putting 1 by 2 with a negative sign. D2 psi by dx square is equal to b of psi. If I compare the coefficient with psi, that is e to the power minus x square by 2, that is constant one is there, so constant doesn't matter for potential, constant is doesn't matter. So we have some x square by 2 minus plus root 2 x tan hyperbolic 2x. So this is what the form of potential. I know the same question is not going to repeat again, but the procedure to find the potential for any given psi is only this procedure we are going to use. Okay, next I'm going to discuss another problem 2, that if we have a psi given as some a sine of x plus b sine of 3x. If someone asks you, is it an eigenstate of energy? Is it eigenstate of position? Is it an eigenstate of momentum? Is it eigenstate of parity? What should you check? So, as there is no any time dependence, so energy is directly discarded. It is not eigenstate of energy. When we are going to find for momentum, we just check. We have a cos x with some constant minus iota h cut. I'm just suppressing that, plus b cos 3x into 3. You can't write this. It may, what I mean to say is the following, that if you are just assuming p acting on psi, you can't find some constant lambda psi. Never, because in starting you have sine, but after differentiating you have cos. Similarly, someone asks you to find, is this a eigenstate for position? Answer is no. because the eigenstate of a position operator is somehow this is delta function. If x is acting on some x prime, you get some delta x minus x prime, this x operator. No, but you can check the parity. How to check the parity? Just put x as minus x. If x minus x, this is minus a sine x minus b sine 3x. Just take minus 1 common and you get your psi. So this is the eigenstate of parity having eigenvalue minus 1. So this is of